So this is a demo of connecting a Viper 200 drive to a Fanuc servo motor, yellow cap DC servo. So here we have a couple Fanuc motors. This is a 5M size, and this is a 10M size. This is off a Bridgeport mill. This was the XY. These were the XY motors, and that was the Z motor. And it's quite a big motor. It has a brake on it as well. But today we're going to be connecting this size here up. So this motor is, just to give you an idea, this motor is 13 inches long and about 5 inches in diameter. And this motor is 17 inches long and 7 inches in diameter, with about 1.5 inches shaft. So the 5M motor, it has a stall current of 9 amps, and that means with the motor completely stalled, you can put a continuous 9 amps through the motor without damaging it. So you have to set the Viper drive to output a maximum of 9 amps continuous. This motor is rated at 161 volts, and at 161 volts it runs 2000 RPM. This motor is rated at 165 volts, 1500 RPM. This motor has a stall current of 12 amps, so this is and 165 volts. Now, so they make the models. They make a M0, M5, M10. But they also make an M20 and an M30. My Viper can handle these three sizes, the M0, M5, and M10. But the other two motors are a little too big for it. So on these motors, you've got the power connector. This one has the power for the brushes. It's a 4-brush motor, but it also has power for the brake here to disable the brake. And over here you got the encoder pins. So here is a pinout of the connections in the encoder connector. You have an A channel, a differential, A channel, differential, B channel, and differential Z channel, or Z channel. Also a common and +5 power. And all those connectors, the A and the B and the power, go directly to the Viper encoder connector. Here I've got a setup with, I've got the Viper tune running on a laptop. I got Mach 3 running on that desktop over there. Here I'm using a power supply running right off the line voltage. It's 167 volts DC, so it's coming right off the 220 volt cable. And I'm running, don't do this at home, but I'm running right into a half-bridge rectifier. And so the common ground on the 220, the neutral, is the center, and it's grounded. But all the power supply and the motor are all grounded for safety here. I've got them grounded to the wall outlet, the 3-prong. And the motor case is grounded, and so nothing is live. You got to be very careful working with a high voltage like this. The power is off right now, so you got 0 voltage here. You got the DC coming in on this connector, and you've got the motor output to the armature, goes on this connector. The encoder comes in from the motor on a twisted pair shielded cable. Got the RS-232, which connects to the laptop, and I'm using a USB adapter here, RS-232 converter. This one here. Then you got the 12 volt coming from a little transformer on the same power supply here, and it's isolated, coming in on 12 volts. And you got the fault and error remote flash connector here. So without the power on, you can freely turn the servo motor here. But when I turn the power on, you see I got 165 volts here. And the Viper is flashing. It's communicating on this side to that side, and the motor is now locked. So I Alright, so if we go over to the Viper tune now, we'll zoom in on this screen. We'll do it's COM9 is where the RS-232 is connected. Do a connect, and you'll see it does a connection here, sends a command to the Viper, and it reads the drive. It's firmware 6.0 Viper 250 HD firmware, and I can do read the drive, and it brings the current parameters in from the drive and displays them here. So I've already done some tuning on this. So the gain is the P value is 800. The derivative is 3 times the P. It's good to keep at least 2 to 3 to 4 times the P value here. Step multiplier is set at 2. The feed forward is at 500, similar to what the P value would be. So if I start the exerciser, you can see the motor is going back and forth there. And I can change the amplitude here. When I go update, go back and forth. So when I start the scope, there's the encoder and the step. And if I reduce the gain here, I'm going to reduce the gain right down. And reduce this one down too. And update the drive. The tuning will be looser. So now you see the more of a difference between the step. So the blue line is the step command pulses, telling it to follow the sharp edge triangle, but the green is what it's reading on the encoder. So you have the green a little off to, and now you have the error here. The error is fairly high. It's approximately 40. Now if I put my hand on this, the error gets worse because it's putting a load on it. But if I increase the P value, and then I'll increase the derivative up to about 4 times what that is, and then I'll hit update, so it gets tighter. And then when I put my hand on, it follows it better. But you can increase the gain more, and I'll increase this number up. I'm increasing the 2 together at once so it doesn't oscillate. So we're going to go about, alright, so it's fairly stiff right there, but I have other videos on tuning. Alright, so there's no step and direction connector connected to the Viper from the Mach 3. Right now it's running on its internal exerciser. So anyway, if I stop the exerciser here, alright, so now we're going to connect the breakout board here. I have a Mach 3 breakout board. I'll connect the x-axis of the Mach 3 to the Viper, and so there I'm running the Mach 3. So I have the Mach 3 here and the drive, and so running from Mach 3 here, just using step and direction. Alright. Now if I with the Viper, if I change the step multiplier here, so you saw that this is as fast it runs at this rate, but let's say I change the step multiplier here to a 3. I'll just hit stop here and do update the drive. Okay, now the motor's going to run faster because for each pulse from Mach 3, the drive makes the motor move 3 pulses. So that's a step of 3. So here we go. Okay. Yeah. Now it monitors the error, and that's the amount. Okay, so if I go to just showing the error here, this is the error of the Viper when it's running like that. Now, so it's running an error about 50 when I plus or minus 50 as I'm jogging it that fast. But if I increase the feed forward, I'll hit update, and now the error is down to 35. So by increasing the feed forward, I can bring that error down. Now, this is a very high resolution encoder on this. So what I'm going to do is I'm going to turn off the main power. See that you can see the voltage going down. It was at 165, now it's going down. And then I'm going to unplug the voltage, the main voltage, to the drive, and so just the front side of the drive is connected, the control side. So we're gonna read just the encoder with the motor not powered. Okay. So what I did was I turned the power off and unplugged the power to the main side of the drive, and I've still got the control side powered. So what I'll do is I'll turn it on. Okay. And so what we're going to do is check the encoder, make sure it's counting. Okay, so here I'm going to turn the motor shaft by hand. So I'm going to zoom in on the Viper screen, the Viper Tune screen here. We're just going to read the encoder. Okay. Now to clear the encoder, right here, we're going to read the encoder count. So to clear the encoder, all I have to do is hit the enable, and it clears the encoder. Now, okay, I'm going to turn the motor approximately 1 full turn. So 1 turn is, I would say it's going to be 12,000 counts. Okay, so the drive has a 4,000 count, a 4 times multiplier. So what that means is the encoder is 3,000 pulses per turn. I guess it's a different encoder than the spec says, because 4 times 3,000 is 12,000. So if I'm going to turn it all the way back, so that's an extremely high resolution encoder on this motor, and it works great. If you use twisted pair wire, you shouldn't have any loss of encoder pulses. Then we turn the power supply off and let that voltage go down. Well, thanks for watching the video. This is the end of the video, and if you email me at larken@storm.ca, and the website is www.larkencnc.com.